Good evening, all of you. So I hope you're comfortable with our first three topics now. Handling numbers, fractions, and rational numbers. So today we'll take a small detour. Squares and square roots is a topic slightly away from the stream, and then we will come back to the stream in the next topic. And today we may have to go a little ahead of time because this module is slightly lengthier, but I thought it was essential to discuss all these things. So we may need about 10 or max 15, not 50. We will wrap it up in about 10 minutes extra, but we may not be able to finish in 1 hour. When I'm explaining, try to pay attention to the screen and what I'm writing. Don't be in a haste of copying down in your notebook when I'm talking, because as it is, I will be sending everything to you as notes. Unless it is something that is not seen on the screen and I'm talking something different and you feel it is very important, then you can just jot it down as a bullet, as a point. And then as soon as the lecture gets over, you will write it down in your own words. That is how you take notes. Okay, so don't be in a haste of copying down as I'm talking. If you feel that there is some new point which is not seen on the screen and I'm explaining something and you feel it is, oh, it is really nice, we have to note it down or I have to think on it, then while I'm talking you will just write in your notebook as a bullet 2-3 words which will remind you of that point, and listen very carefully what I'm talking. And then as soon as the lecture gets over, immediately you can elaborate that particular point, explain it in your own words, or think of that example, whatever. Okay, so we stretch our memory and respect our memory that yes, this much I will definitely remember. I'll not forget what ma'am was talking. With these 2-3 words, I can take a hint and I can write it by myself after the session is over. And pay close attention to what I'm talking and understanding it, what I'm talking carefully. And where you have not understood, you can note down that time of the video, maybe because we are also sending the video. So if I'm talking something and you're not following that point, just note that, oh, it is around 15 minutes time or it is around 25 minutes time. So if you don't wish to see the whole video, you can just go to that point of the YouTube video and just listen to that one thing that you've not understood. What you understood, you need not see the whole video again and again. No. So wherever you feel that, oh, this is something important, I need to listen to it once again, just note down that time, around that time. Okay, that will help you in quickly reaching to that particular point which you have not understood. Okay, it's 7 o'clock, so let us start. We are starting with a fresh topic today, squares and square roots. Now I'm very sure all of you are very much familiar with this word. Okay, we also know this square, isn't it? Square in geometry. and this is the square of numbers. So when we use the word square of a number, it simply means the number multiplied by itself. So it is the same number multiplied by the same number, or one number taken as many times as the number. What is 5 into 5? 5 taken 5 times, no? So 5 plus 5 plus 5 plus 5 plus 5. What is 25 into 25? 25 taken 25 times. So square in geometry is a figure with 2 dimensions, length and breadth. And square in arithmetic is a number multiplied by itself. So as such, this also has 2 dimensions. Same number 2 times. Here, square is figure with 2 length and breadth, and both are equal. And here also these 2 are equal. So as such, this square and this square, we can relate it on a very lighter note. And now the terms, suppose I am writing, want to say square of 5, I can call it as square of 5, 5 square, and I will write it as 5 and superscript 2. When we will learn indices, this is also called as index. This is also called as index, and this is called as base when we learn indices. So when we express square, this form is called as the exponential form, where we have a base and a number raised to it. So I can read it as 5 square or 5 raised to 2 or square of 5. And I will essentially write it as 5 and a small 2 on the right top corner of it. This is the only way how we numerically express square of a number. And then its value will be 25. So I will write 5 square is equal to 25. And the other way around, how will I write 5 with respect to 25? If 25 is the square of 5, then 5 is the square root of 25. If 25 is the square of 5, then 5 is the square root of 25. And what is the symbol used for it? It is this symbol. Either simply this much, or when we write it in our notebooks, we most popularly write it like this. So this is the symbol for root. And when it is square root, I'm not writing any number in this pocket. I don't write 2 in this pocket. When nothing is written, it is square root. Okay. So both these exponential and this root form, we will learn better when we will learn indices. If I am writing 3 in this pocket, that is cube root. So if I take 5 3 times, it will be called as 5 cube. That will be 5 5s are 25, 5s are 125. And then I want to write 5 in terms of 125. I will say cube root of 125. So whichever root, that number we write in this pocket of this sign, but for square root, we write nothing. So when nothing is written in this pocket, that means square root. Understand the terms? Number multiplied by itself is square, written like this. And the number which is square, the square root of that is our number with which we start, and it is written like this. Now, a very important property about square. Okay, we have seen now that if we multiply two positive numbers, our answer is positive. We have seen it in fractions also. When both the numerator and denominator are positive, it is positive. When we multiply two negative numbers, then also our answer is positive. And when I'm finding square, I'm multiplying the number by itself. So I will never multiply plus 5 by minus 5 to find a square. This product will be minus 25. But when I'm finding a square, I'm either multiplying 5 by 5 or minus 5 by minus 5. So understand that whether it is 5 square or whether it is minus 5 square, my answer will always be plus 25. So the square is never negative. Square number is always positive, but the square root can be positive or negative. So when I am saying that the square of a certain number is 25, what is that number? That number can be plus 5 or it can be minus 5, any of the two. Please understand this. When I'm saying 25 is a square number, and what is its square root? It can be plus or minus. But square is always positive. Remember this very important property. Square root can be positive or negative. Square is always positive. And ideally, so how we write it? We write it as square root of 25 is equal to plus or minus 5. This is the sign we use for plus or minus. It can be plus or it can be minus. The meaning of this sign is both are possible, plus or minus 5. We read it as square root of 25 is plus or minus 5. Very important property. You have to keep it in mind because this is sometimes used to generate multiple answers in MCQs. What is the square root of 25? Both plus 5 and minus 5 are correct answers. So this property can generate multiple options in MCQs. So very important. Now, another term that is very commonly used is a perfect square. Now we have to understand that 25 is a perfect square because we get it as a product of two natural numbers. But suppose I'm going to multiply 5.25 or say some number and 5 to itself, I am going to get some number, but it will not be a natural number. It will not be a natural number. And therefore, that number is a square, but it is not a perfect square. Understand this term. Only those natural numbers which are the exact squares of some natural number are called as perfect squares. Otherwise, every number can be a square number, but its square root is not going to be a natural number. It will be a rational number. It may also be an irrational number. Okay, so understand this term perfect square. The squares of natural numbers are called as perfect squares. Other numbers which can also be square numbers or which are square numbers, as such every number I can get as a product of two same numbers, but those two same numbers will not be natural numbers and therefore that number will not be called as a perfect square. Okay. Now, all these points clearly understood. We are going slightly fast, but I guess I've repeated it sufficient number of times that you've understood these points. Now, let us see the squares of numbers from 1 to 10. 1 square will be 1. 1 into 1 will be 1. All of you all will be knowing most of this. 2 square is 4. 2 into 2 is 4. 3 square is 9. Please take a note that we are doing 3 into 3. Sometimes what children do is they will write 3 square as 3 into 2. 2 times 3 means they will say 3 into 2, 6. This is not 3 square. I am multiplying 3 by 3. So 2 times 3 will be expressed as 3 raised to 2 and not 3 into 2. This is a wrong way of writing. And 3 2s are 6. They will take it as 3 square. No. Number multiplied by 2 is not its square number. Number multiplied by itself is square. So 3 square is 9. 4 square is 4 into 4, 16. 5 square is 25. 5 5s are. 6 square is 6. 6 are 36. 7 7s are 49. 8 8s are 64. 9 9s are 81 and 10 10s are 100. These are the squares of numbers from 1 to 10. Now what will be 11 square? Whatever comes before, the last number will be 1. Because what is 11 square? 11 multiplied by 11. And therefore the units place will always be 1 1s are 1. Something will come here. Understand that. Then what will be 21 square? Anything that comes before, but 1 1s are 1. So units place will be 1. Units place will not change. Then what will be 47 square? It will be 47 multiplied by 47. So anything may come in the tens and hundreds place. But what about the units place? Units place will stay 7 7s are 49. 9. What will be 89 square? 9 9s are 81. Units place will stay 1. Then number over here may be different. So once I know the squares of all numbers from 1 to 10, I have to understand that any number ending with 1, its square will always end with 1. Any number ending with 4, its square will always end with 6. Any number ending with 8, its square will always end with 4. So if any number is ending with 4 and somebody is telling me that this is a perfect square, what do I understand? If the square is ending with 4, square root should end with 8 or 2. If this number is ending with 4 and someone has told me that it is a square number, what does that tell me? The square root must have 2 or 8 as its units place, square root. So once I know the units place of the square, I will know the units place of the square root for sure. The rest of the things I may have to find out, but I will know the place of square root for sure. So that is also one table that I have made, that if the square ends with 1, square root will end with 1 or 9. If the square is ending with 1, square root is ending with 1 or 9. If the square is ending with 4, then the square root will end with 2 or 8. If the square is ending with 4, square root will end with 2 or 8. If the square is ending with 9, square root will end with 3 or 7. If the square is ending with 9, square root will end with 3 or 7. If the square root is a square is ending with 6, square root will end with the 4 or 6. See how it is going? 1, 2, 3, 4, 5, 6, 7, 8, 9. Pairs, see how the pairs are forming? 1 and 9 are forming a pair. Square ends with 1. 2 and 8 are forming a pair. Square ends with 4. 3 and 7 are forming a pair. Square ends with 9. 4 and 6 are forming a pair. If the square root ends with 4 or 6, square will end with 6. Then 5 बेचारा अकेला पड़ गया बीच में, तो उसने क्या कहा, अब मेरे को अकेला छोड़ दिया ना, तो मेरे एंड में मेरे को 2 नंबर चाहिए. ये सब यहाँ पे जोड़ी है, यहाँ पे अकेला है, ये यहाँ पे अकेला है, तो वो बोल रहा है मेरे को 2 नंबर चाहिए. तो every number that ends with 5, its square will always end with 25. So if there is some number which has 5 in its units place and not 2 in the tens place, 35, 45, this cannot be a square number. If it is a square number, it has to have 25 in the tens and units place. Note that. Only then it is a square number. And every number ending with 0 will have 2 zeros in the square. Because I am multiplying 10 by 10, the square has to have 2 zeros. A square number can never have 1 zero in the units place. It will always have 2 zeros. So looking at the units place of the square, we always come to know what comes in the units place of the square root. And in this whole thing, have you noticed that these 4 digits are not coming anywhere in the units place? There is no 2, no 3, no 7, no 8 in the units place of any square number. So if someone is giving me a number ending with 8, I have to be sure it can never be a square number. If it is a square number, it can never end with 2 or 3 or 7 or 8, because यहाँ पे कहीं भी 2, 3, 7, 8 नहीं है. So that is also like a hint, first hint to identify whether some number will be a square number or not. Okay, now let us do 1 or 2 examples. If 11 square is 121, what will be 110 square? Now look here, 11 square is 11 into 11, and the answer is given to me 121. Now if I'm finding 110 into 110, what is the only thing that is going to change? This 0. So my answer will be 21 and 2 zeros. This is one way how I can do it. Or how I can do it, 110 is 11 into 10 square. So it is 121 into 100. That is 12100. Simplest way is, there is 1 0 on the square root. There will be 2 zeros on the square number. That will be my answer, 12100. Then second question, can, what is this, 1 units, tens, hundreds, thousand, 1 lakh. Can 1 lakh be a square number? Now see, 1 lakh has 5 zeros on it. Suppose I take 10 square, it will be 100. That means 2 zeros. Suppose I take, this is all zeros. So this is going to be a square of some multiple of 10 only. No, there can't be any other number. Suppose I take 100 square, then I will have 4 zeros on it. These 2 zeros and these 2 zeros. And suppose I take 1000 square, I will have 6 zeros on it. 3 zeros once and 3 zeros twice. So if a number has 5 zeros, for that matter, any odd number of zeros in the end, it cannot be a square number. So a square number must essentially have even number of zeros in the end. In between, there can be some more zeros depending upon what the number is. But in the end, the number of zeros should always be in a multiple of 2. 2, 4, 6, 8, whatever. So this cannot be a square number. Okay. Then, is 15 square is equal to 10 square plus 5 square? Let us see. 15 square, there is a shortcut to find the square of numbers ending with 5. We know that any square root ending with 5, the last 2 digits are always 25. So see a square root ending with 5, straight away write 25 as a units and tens digit of the square number. Then remaining part of the number, after 5, what is there? 1. Multiply that by the next consecutive number. If it is 1 multiplied by 2, 1 2s are 2. Write it before this 25. This is 15 square 225. For any number ending with 5, this is the shortcut by which you can find the answer. Write 25 in the units place, multiply the remaining part of the number by the next consecutive number and write that number before 25 to get the square of that number. So 15 square is 225. So my left hand side is 225. Now let me check out the value of my right hand side. What is 10 square? It is 100. What is 5 square? It is 25. So what is 100 plus 25? 125. So is 15 square equal to 10 square plus 5 square? My answer is no. 15 square is not equal to 10 square plus 5 square. Now, what is the difference in the answer? 15 square is 225 and 10 square plus 5 square is 125. Difference is 100. This is your research problem. Take number of such pairs. You can take 10 square and 7 square plus 3 square. Then take 18 square and take 12 square plus 6 square. You can choose many such innumerable such pairs, find the square of the number and find the sum of the squares of two numbers adding to that number. Have you understood what I'm trying to tell you? Select a number and express it as a sum of two numbers. Express it as a sum of two numbers. You can express this as 6 plus 4. You can express this as 7 plus 3. And find if 10 square is 6 square plus 4 square. No. What is the difference coming? Find it out every time. And find if you can find some specific thing about that difference. So every time I'm adding that much to this total and I'm getting the square of this. Investigate if you can come to some generalization when we do these kind of sums. So this is your research problem. Why this happens, and is there some specific number every time, and then can I predict that number, that if I add this to this number, I will get the answer equal to the bigger number. That is your research problem. Now I already told you how to find the square of numbers ending with 5. Take any number ending with 5, and if I have to find its square, I will simply write, for example, take 25 square. I will write 25 because a number is ending with 5. Then what remains after 25? 2. I will multiply 2 by the next number 3. Okay, what is 2 3s are 6. So I will write 6 before 25. 25 square is 625. If I want to find 35 square, I will write 25 as a rule, and I will multiply 3 by 4, the next number. 3 4s are 12. So 35 square is 1225. Shortcut. So any number ending with 5, I can find. If I want to find the square of 135, then what will I do? Write 25 and multiply 13 by 14. Whatever remains after removing 5, multiplied by the next number, write it before 25, you will get the answer. So shortcut for numbers ending with 5. You don't have to actually multiply. Then shortcuts for number ending with 1. We've already seen that if the square root ends with 1, the square will always end with 1. And for the remaining part, what I will do, I will take the whole number, multiply it by the digit in the tens number, and add that number to it. So 11 ones are 11 plus 1, 12. 121 is my 11 square. Any number ending with 1, units place is, multiply the whole number by the number in the tens place or whatever remains after 1 is removed, and add the same number to it. Suppose I want to find 21 square. 1 will come here. I will multiply 21 by 2, the number in the tens place. That is 42. And to that, I will add this 2 again. That gives me 44. So 21 square is 441. This is the shortcut for finding the squares of numbers ending with 1. So these were 2 very handy shortcuts. And now one shortcut we are going to see to find the square of any 2-digit number. To find the square of any 2-digit. We will do it with the help of an example. I have given the explanation over here. This you can read later on because the explanation is little clumsy, but actually it is not that clumsy. Actually, it is very easy. So let us see any 2-digit number 34. I want to find the square of 34. I want to find the square of 34. See the steps, everybody at the board. I will find the square of the number in the units place. What is 4 square? 16. Okay. And this is my final answer ka box. 4 square 16. I will write the units digit of this over here as my units digit of the final answer. And I will carry over 1 to the second step. Square of 4 units digit comes in the units digit of my final answer. 1 goes to the second step. Then next step is I will multiply 4 by 3. 4 3s are 12, and whatever answer comes, I will multiply it by 2. So 4 3s are 12, 12 2s are 24. To this 24, I will add this 1. I will get 25. Now, this 5 I will write in the tens place of the answer. And I will take this 2 to the third step. Then I will find the square of the tens digit. 3 square is 9. To this 9, I will add this 2. I get 11. I write 11 over here. So 1156 is my square of 34. Okay, let us see it once again. 4 squared 16, 6 written in the units place of the answer, 1 carried over to the second step. Second step, 3 into 4, 12 into 2, 24 plus carried over 1, 25. 5 written in the tens place of the answer, 2 carried to the step 3. Step 3, 3 square 9 plus 2 11, 1156 is my answer. So I don't have to multiply. Actually 34 by 34, the answer comes in 30 seconds. This is a very, very fast shortcut, and this is not a magic. We will very easily prove this, but we need some more tools which you may not have with you right now. So you may not be able to work on this proof just now. But little ahead, maybe in a very few days, we will be able to prove why this kind of a formula works. Right now, you will just use these 3 tools: number ending with 1, number ending with 5, number ending or any two digit number. So let us, as a quick example, do all these 3 squares by using the shortcuts. 35 ends with 5. So if I want to find the square of it, I will write it as 5. So it will end with 25, and I will multiply 3 by 4 to get the square of 35. 1225. 1225 will be 35 square. Then I want to find 66 square. Step 1, 6 square 36. I write 6. I carry over 3. मनु रिमोट कंट्रोल ऑफ स्क्रीन अप्रूव करू का डिक्लाइन करू? प्रशांत
काय झालं?
रिमोट कंट्रोल ऑफ स्क्रीन आला रिक्वेस्ट डिक्लाइन केली मी आता.
हो डिक्लाइन असतं.
हो ना? Yeah. So 6 square 36, 6 comes here, I carry over 3. Step 2, 6 into 6, 36. Arey, no, I'm not going to give any remote control to any student. Please don't ask any remote control or request over here. Nobody can operate the screen over here when I'm taking the session. Stop playing mischiefs, otherwise we'll have to remove you out of the classroom. No pranks. This is a consecutive second request I have got of operating remote control, screen by remote control. Nobody is doing that. 6 into step 2 is 6 6 are 36 plus 3. Whatever I've carried over gives me 39. I will write 9 over here and I'll again carry over 3. And step 3 is 6 squares are 6 square is 36 again. And sorry, I did a mistake in the second step. Second step. Don't distract me, Baba. Don't distract me. 6 square is 36. 6 carry over 3 in the first step. Second step, 6 6 are 36 into 2. That is 72. 72 plus 3 will be 75. So 5 and 7 carried over. And third step is 6 square 36 plus 7 gives me 43. So the square of 66 is 4356. And note that this is falling between 60 square 3600 and 70 square 4900. We are going to use this technique to find the square root as we go ahead. If someone tells me 4356 is a square, how will I find its square root? 4356 falls between 60 square and 70 square and it ends with 6. So if this is a square, its square root is 64 or 66. That is how we are going to come back to the same number later on. And square of 31, like we saw just now, units place is 1. For the tens place, I will multiply 31 by the number in the tens place, that is 3. 31 into 3 is 93. And to that, I will add the same number. 93 plus 3 is 96. So square of 31 is 961. So you can play a lot. You can take any 2-digit number and play a 10-second, 15-second game with your friends who comes out with the answer fastest. You can find the squares of all 2-digit numbers, and your homework assignment is, can we find the square of 114 using the same method? What can we do in that case? Can I use the same formula of 2-digit to find the square of 114? Find out method. So then your method does not stay restricted to 2 digits. You can convert the same method to 3 digits, 4 digits, whatever. So this is your homework assignment. Now, just like we found squares, we can find the square roots also. Suppose now let us take the same number 4356. Now I know that this is a square of 66. How will I come to 66 using this? There are two methods. One method is I will do the prime factorization of 4356. Meaning I will find the factors of 4356. 4356 is what? Let us take some smaller numbers. So we will spend less time because I have to squeeze a lot in this hour. So let us take a small number. If I want to find the square root, I can find it by two methods. Suppose I want to find the square root of 36. I have purposely taken a small number because then we will need lesser time. So I will do the factorization of 36. Okay. What is 36? It is 2 multiplied by 18. That is 2 multiplied by 2 multiplied by 9. This is how we do prime factorization. Always start from the smallest prime factor and then rise up. Then it is 2 multiplied by 2 multiplied by 3 multiplied by 3. So now see, these are the prime factors of 36. If 36 is a square number, the prime factors will be in perfect two sets, perfect two identical sets. A square number can be made into two perfect identical sets. I can divide this 2 and 3 into one pair of 2, 3, another pair of 2, 3. So one of the pair is the square root of this number. So 2 3s are 6 is the square root of 36. Remember that. So if I prime factorize the number, if it is a square number, the prime factors will form two identical sets, and one of the set is the square root of the given number. And another method is what we discussed just now. 36. It falls between, or let us take a bigger number now. Let us take this number 1444. Someone has told me that 1444 is a square number. Okay, then I have to find two square numbers of multiples of 10. Okay, what do I find? 30 square, 900, and 40 square, 1600. I will essentially find two multiples of 10 between whose square my number lies. So 1444 lies between 900, that is 30 square, and 1600, that is 40 square. So square root of 1444 should lie between 30 and 40. And it is ending with 4. If my square ends with 4, my square root ends with either 30, either 2 or 8. If this is a square number between 30 and 40, and if it is ending with 4, the square root should end with 2 or 8. And which are the numbers ending with 2 or 8 between 30 and 40? 32 and 38. Now, one option is I actually find the squares of these two. But I have one more step. I know my square of 35. I can very easily find my square of 35 is 1225. And 1444 is greater than 1225. So it cannot be the square of 32. So the only option left with me is 38. And therefore 1444 is 38 square. Let me repeat it once again. For whatever given number. Now let us do it for our 4356. 4356. Root of 4356. This is called as approximation method. Now we know it is 66 square. So 60 square, 3600, and 70 square, 4900. 66 falls between these two. And 65 square is, and because the square is ending with 6, the square root will end with 4 or 6. So this is possibly the square of 64 or 66. But 65 square is 5 5s are 25 and 6 7s are 42. 4225. It is greater than 4225. So this has to be 66 square. It cannot be 64 square. So this is called as the approximation method of finding square roots. So we have seen two methods of finding square roots, and we have seen three shortcuts of finding squares of numbers ending with 1, ending with 5, and any two-digit number. Now the next point that we are going to see is, if I am given a number 18, it is not a square number. I want to make it into a square number. in the next square number. What will I do? I will prime factorize 2 into 9. That will be 2 into 3 into 3. Now, if I want this to be a square number, I need pairs. I have a pair of 3. I don't have a pair of 2. So if I create a pair of 2, that means I multiply this by 2. That will be the next possible square number. So by creating a pair, I can convert a non-square number into a square number by multiplying it by a suitable number or by dividing it by a suitable number. If I prime factorize 72, I will get 2 into 2. Again, someone is requesting remote control. What is this happening? Who's playing this mischief? Who's playing this mischief? Prime factorization of 72 comes 2 into 2 into 3 into 3 into 2. So I have one pair of 2, one pair of 3 and one extra 2. I want to convert it into a square number. I can remove this 2. 72 divided by 2 will be 36. So I can convert a non-square number into a square number either by multiplying it by a number that will create a pair or dividing it by a number that will create or that will remove the unpaired number. This is a very typical sum that is asked. Okay, and then let us see the operation on numbers in square root. Very importantly, we need to understand that sum of square numbers is not the sum of their squares. What is root 4 plus root 9? Root 4, सुश्रुत तेंडुलकर, प्रशांत, सुश्रुत तेंडुलकरला बाहेर काढ रे. प्रशांत, are you there?
काय करू?
सुश्रुत तेंडुलकरला remove him out of the meeting.
Okay.
Whoever is going to ask the remote control and all that, I'm going to remove him out of the meeting. Absolutely no mischiefs. So root 4 plus root 9. What is root 4? It is 2. And what is root 9? It is 3. So root 4 plus root 9, correct answer is 5. And it is not equal to under root of 4 plus 9. Under root of 4 plus 9 is under root of 13, which is not equal to 5. So please understand, root 4 plus root 9 is not equal to root of 4 plus 9. You have to find separate values and then add. Similarly, root 9 minus root 4, correct answer will be 3 minus 2, that is 1. But root 9 minus root 4, if I do it like this, it becomes root 5, which is not 1. So for addition and subtraction of roots, we have to find separate values and add. It is not the under root value of the sum or difference. But for multiplication and division, it becomes the same. Root 4 is 2 and root 9 is 3. What is 2 into 3? 6. And what is root of 4 into 9? 4 into 9 is 36. What is root of 36? it is also 6. So root 4 into root 9 is equal to root of 4 into 9. So if it is multiplication, I can combine both the numbers and take it into common root sign and find the answer. Similarly, if it is division, root 36 is 6 and root 9 is 3. 6 upon 3 is 2. And what is root of 36 upon 9? 9 fours are 36. Root of 36 upon 9 is root of 4, which is 2. So for multiplication and division, you can take the numbers in combined under the root sign, but for addition and subtraction, you cannot take the numbers combined in root sign. You have to operate separately and only then you will get the correct answers. Please remember this. Okay. And then we will have some simplification sums. Suppose I have to simplify 6 upon root 2. How will I do this? I know 6 is 2 into 3. I know 6 is 2 multiplied by 3. So 6 upon root 2 is 2 multiplied by 3 upon root 2. Now this 2 I can also write as root 2 into root 2. Root 2 into root 2 is the number. This is not a perfect square because root 2 does not have a natural number as its value. So this is an irrational number. But still, I can express it as root 2 into root 2 into 3 as it is upon root 2. So since it is all in multiplication division, I can cancel root 2 to root 2 and my answer comes 3 root 2. And I keep it as it is. And I will write it as 3 root 2. Remember that. Once again, I will write 6 as 2 into 3. Then I will write 2 as root 2 into root 2. And then I will cancel 1 root 2 to the root 2 in denominator. And then what remains 3 root 2 is my final answer. I will keep it as it is. I will not do anything with this. And this is not 3 plus root 2. This is 3 multiplied by root 2. The multiplication sign is not written. It is understood. Okay, so let us quickly see a few examples. As I said, it's already 8 o'clock and we may need 10-15 minutes to see through the examples. So as I already declared or I've put on the group, we will have to extend our today's session. But I thought all this discussion was extremely essential. And I'm sure after 6 sessions, now you can sit for 15 minutes extra very happily. Let us quickly see the sums now. Root 25 plus root 36. Now, root 25 can be plus or minus 5. And root 36 can be plus or minus 6. So root 25 plus root 36 can be plus 5 plus 6, minus 5 minus 6, plus 5 minus 6 or minus 5 plus 6, any combination. I can take root 25 minus 5 root 6 plus. So I will have 4 answers ideally over here. It can be plus 11, it can be minus 11, it can be minus 1 or it can be plus 1. But when it is not mentioned, we always take the positive values of the square root. If it is not mentioned, if they say find all the values, then we will have 4 answers. All these 4 answers can be as such correct because root 25 can be anything of this and root 36 can be anything of this. But when it is not mentioned, we will take only the positive value, and so the only answer will be 11, which will be given correct. Okay, but if they say find multiple answers, then we can find actually 4 answers. So I want you to find all possible answers for all the questions. We will find only one answer here. We will see, take only the positive square roots and find the answers over here. But at home, you can find all the possible answers, taking both the positive and negative values of root. Then square root of 25 into 36. Square root of 25 is 5. Square root of 36 is 6. 5 multiplied by 6 is 30. So the positive answer of this is 30. Then third is root 25 plus root 36. That is 5 plus 6 upon 5 into 6, that is 30. So the answer over here will be 11 upon 30. The one answer by taking positive roots. As I said, I will take only should we take. If we want more answers, we will
Madam got disconnected actually. Just wait for 2 minutes.
yeah. Can you hear me now? Yes. Okay. So let us continue. I thought it was 1 hour meeting, so that is why. Okay. So now our next question is 25 into 36. उसको भी सिस्टम को भी पता चला 1 घंटे का लेक्चर है. That will be 5 into 6 upon 5 into 6. That will be 1. So these were 4 easy questions. Okay. Now a little step up questions. The square of a number multiplied by 37 gives 333. My number will be x. Square of x multiplied by 37 gives me 333. X square into 37 is 333. Find the value of the number. I will simply take this 37 on this side. Multiplication becomes division. So x square becomes 333 divided by 37. That is 9. And if x square is 9, x is ideally plus or minus 3, but we will take it as 3. But plus or minus 3 is fine. So the number is plus or minus 3. Okay. I formulated this particular equation using the information given. Then find the square root of 36864. At home, you will do it by factorization also. Do the prime factorization and do it. We will do it over here by approximation. Okay. If I see 36864, 200 square. See what I'm doing? 200 square is 4 and 4 zeros. It is 2 with 2 zeros. So square of this will be 40,000. And 190 square. 190 square will be 36,100. So my square number lies between 190 square and 200 square. And it is ending with 4. So if the square is ending with 4, square root will end with 2 or 8. And now when I find 195 square, I get it as 38025, which is greater than this. Therefore, this cannot be 198 square. So this is 192 square. And I can also observe that 36864 is so close to 36100. No? Now imagine this is 190 square. Huh? Look at it position wise. This is 190 square. 190 square is 36100. 200 square is 40,000. And my square is 36864. It is so close to this number than this number. So if my options are 192 and 198, by judgment also I come to know that it cannot be close to this. If it was 198 square, the value would have come close to 40,000. My value is much close to 190 square. Therefore, the possibility is 192 than 198. And I confirm it with 195 square. 195 square is 38025. So it is smaller than this. So this is 192 square. So use your shortcuts, your judgments, the options available with you all together and to find your answers. Next question. Root of 16 plus root of 64 is a plus 70. What is root of 16? 4. What is root of 64? 8. So 8 fours are 32 is 17 plus 8. What will be A? I will simply transfer this 17 on this side. So A will be 32 minus 17, that is 50. That was simple. Then let us go to the next. Root of 225. Now I know it is 50. Plus root of 25. I know it is 5. Upon root of 64, that is 8, minus root of 36, that is 6. So this is 15. Now I cannot cancel this to this. Please remember, I cannot do it 3 2s are 6, 3 5s are 15. It is all plus minus. No cancellation when it is plus minus. I can cancel only when it is multiplication division. So I have to imandari se find the value of numerator 15 plus 5, 20. Value of denominator 8 minus 6, 2. And now I can cancel 2 1s are 2 10s are. But if you cancel it here, 3 2s are 6, 3 5s are 15. 5 plus 5, 10 upon 6. Gaye kam se. Wrong. No cancellation with plus minus around. Cancellation only when it is multiplication division. Okay. So the answer for this is 20 upon 2, 10. And now the last one, root of x is equal to root of 36, that is 6, into 8 upon 3. Now here it is multiplication. So I can cancel this 3 1s are 3 2s are. So root of 8 is 8 2s are 16. So what will be x? If I want to find x, it will be the square of this. And if I'm squaring the LHS, I have to square the RHS also. So root of x square, Jayvardhan Gupta is again asking me remote control. What is this new thing happening today? Root of x square is x and 16 square is 256. So my value of x becomes 256. Okay. Those were our sums for today. As predicted, we have taken 15 minutes extra, and I know this was a little fast and this little heavily packed lecture. You all will need a very good homework today. So carefully go through the YouTube video, all of you. Understand whatever properties we have learned. First, do all these questions once again by yourself and then go for the practice questions. I will send the practice questions also. First, again, do these 9 questions all by yourself because I will not be sending the answers to you right now. So first do this. Looking at the YouTube, you will get the solutions and then jump in for your lecture 8 practice questions. Okay. We will meet on the next class on Thursday. That day, we may not need extra time. Okay. And whoever is asking that remote control permission and all that, please stop on mischiefs. Okay. No mischiefs. We stop for today. Bye.